Welcome to our channel, Math Defined. This video will focus on evaluating powers and solving expressions with exponents. First, we'll review how to find the value of exponents, and then we'll look at 7 different types of expressions to solve. The last expression will be the most challenging because the bases are fractions. You won't want to miss that. Before we can solve expressions with exponents in them, we need to understand what they are and how to evaluate them or how to find their values. Here we have 3 to the 4th power. Let's first identify its parts. The 4 is the exponent, the 3 is the base, and together these two parts create a power. But what do all these words mean? A power is the product of a repeated factor. The base is the repeated factor, and the exponent indicates the number of times the factor or the base is repeatedly multiplied to itself. Now let's review how to find the value or solve for an exponent or power. Here we have the power 3 to the 4th written in 4 different scenarios. All 4 will have a product of 81. But 2 of them will be positive 81 and 2 will be negative 81. Can you spot which 2 will be positive and which will be negative? For the first scenario, we have positive 3 to the 4th power. I know that the 3, or the base, is positive because there is no negative sign to the left of it. To find the value, we just need to multiply the base of positive 3 to itself 4 times. I like to multiply in small chunks. So I'll multiply this first pair of 3's to get 9, and then this next pair of 3's. And then I'll multiply the 9's to get the final product of positive 81. So this is our first positive 81 product. Do you see the other positive 81? This might be a challenge since the other 3 powers all have a negative sign attached in some way. When finding the values of negative numbers with exponents, you need to ask yourself, what is the base number? In this second scenario, we have negative 3 to the 4th power with the negative 3 in parentheses. What is the base number? The parenthesis is next to the exponent, so this means that everything inside the parentheses is the base number, including the negative sign. To find the value, we multiply negative 3 to itself 4 times. Again, I like to multiply in small chunks, and negative 3 times negative 3 results in positive 9. And positive 9 times positive 9 is positive 81. So now we have our 2 positive products. So the last 2 scenarios will result in a product of negative 81. What is the base number in this third scenario? The parenthesis is next to the exponent. So everything inside the parentheses is the base. Do you see that the negative sign is not inside the parentheses? Only the positive 3 and not the negative sign is being raised to the 4th power. So we will multiply positive 3 to itself 4 times to get positive 81. And then bring down the negative sign to get a value of negative 81. In this fourth scenario, the number 3 is next to the exponent with no parenthesis between them. What is the base number? When a power is written this way, it means that only the positive 3 and not the negative sign is being raised to the 4th power. So the base number here is positive 3. And we'll multiply the base number of positive 3 to itself 4 times to get positive 81, and then bring down the negative sign for a value of negative 81. Now let's move on to solving expressions with exponents in them. It's important to remember that when solving any type of expression, you must follow the order of operations. So whether you like to use PEMDAS or GEMS or even BODMAS, it's important to follow the correct order. Starting with the first expression, we have 3 plus 2 times 3 to the 4th power. Following order of operations, we need to simplify or find the value of 3 to the 4th power first. This one is easy because we just did this a few minutes ago. The value of positive 3 to the fourth power is found by multiplying the base, or positive 3, to itself 4 times to get positive 81, and we'll bring down the rest of the expression. The next operation we need to complete is multiplying 2 times 81 to get 162. And the last operation is addition, and 3 plus 162 is 165. Moving on to problem number 2, we have negative 3 times the quantity, negative 10 squared plus 70. We need to solve what is in the parentheses first. And then within these parentheses, we need to simplify the exponent first. Remember, when working with negatives, you need to ask yourself, what is the base? The number 10 is next to the exponent with no parenthesis between them. So only the 10 and not the negative sign is squared. Positive 10 squared is 100, and we'll bring down the negative sign along with the rest of the expression. We still have the parentheses, so the next operation is to combine or add negative 100 plus 70 to get negative 30. And the last operation is multiplying negative 3 to negative 30 to get positive 90. Looking at this third problem, we will need to begin simplifying within the parentheses first. Following the order of operations, we will simplify the exponent first. Here again, we see a negative sign with the power. So we need to ask ourselves, what is the base? Since the number 4 is next to the exponent with no parenthesis between them, the base of this power is positive 4, and we will multiply it to itself 3 times to get positive 64. And we'll bring down the negative sign along with the rest of the expression. We still have parentheses, so the next operation we need to complete is 7 times 4 to get 28. The last operation inside the parentheses is subtraction, and 28 minus 64 is negative 36. The parentheses are finally gone, and all we have left to do is divide negative 36 by 6 to get negative 6. Instead of parentheses, in problem number 4, we have absolute value bars, which is a grouping symbol similar to parentheses, but we have to remember that the value of anything inside absolute value bars will be positive. Following order of operations, we will simplify the exponent first. Here again, we see another negative sign, so we ask ourselves the question, what is the base? The number 3 is next to the exponent of 3 with no parenthesis between them. So the base is positive 3, and we'll multiply it to itself 3 times to get positive 27, and we'll bring down the negative sign along with the rest of the expression. The last operation inside the absolute value bars that we need to complete is negative 27 divided by positive 27 to get negative 1. And then we need to get rid of the absolute value bars by making the negative 1 a positive 1. Hopefully you're feeling more confident now, so I encourage you to pause the video and solve these next 2 expressions on your own. When you're done, you can check your work, and then we'll move on to a more challenging expression where the bases for the powers are fractions. All right, let's tackle expression number 5. Following order of operations, we need to solve for the exponent first. We have a negative sign attached to the number 3 inside parentheses. What is the base? Since the parenthesis is next to the exponent, this means that everything inside the parentheses is the base. So the base number is negative 3, and we'll multiply negative 3 to itself 2 times, resulting in positive 9, and we'll bring down the rest of the expression. Next, we will multiply 7 by 9 to get 63. The last operation is addition, and 2 plus 63 is 65. Moving next to problem number 6, we need to start inside the parentheses again. And within the parentheses, we need to simplify the exponent first. What is the base? There is no parenthesis between the exponent and the number 6, so the base is positive 6, and we'll multiply it to itself 2 times to get positive 36. We'll bring down the negative sign along with the rest of the expression. Still working inside the parentheses, we need to add negative 4 and 12 to get positive 8. And there is still one operation left in the parentheses, 8 minus 36, which is negative 28. The final operation is negative 28 divided by 7 to get negative 4. If you've been enjoying the content on our channel and want to show your support, here are some ways you can help us grow and keep creating awesome videos for you. Your support fuels our passion for creating content, and we're incredibly grateful for each and every one of you. Together, let's continue to grow and build an amazing community. Thank you for being part of our journey. Now, are you ready for a challenge? This time, not only do we have exponents, but we have fractions and absolute value bars. Take a deep breath and try to solve this one on your own. I'll have the answer ready when you are done. Okay, this problem has these absolute value bars, so we know that the final answer will be positive. So starting inside, we need to simplify the first power on the left, negative 1/2 to the third power. What is the base? The parenthesis is next to the exponent, so this means that everything inside the parentheses is the base number. So we'll multiply the base, negative 1/2, to itself 3 times. We'll multiply the numerators and the denominators straight across to get negative 1/8, and we'll bring down the rest of the expression. Next, we need to simplify 1/4 squared. What is the base? The parenthesis is between the 1/4 and the exponent, so everything inside the parentheses is the base. The base here is positive 1/4, so we'll multiply 1/4 to itself 2 times to get positive 1/16. Remember, to divide fractions, we keep the first fraction of negative 1/8 and then multiply by the reciprocal of 1/16 by flipping it to 16 over 1. Now I see that we can simplify before we multiply by cross-canceling 8 and 16. Multiplying the numerators and the denominators straight across, we get negative 2 over 1, which simplifies to negative 2. The last step is to simplify the absolute value of negative 2 to positive 2, and we're done. I hope this helped you out. Until next time, keep math awesome.